So we are gonna try this and see how it works. Um, I'm here at the U.S. Virgin Islands, and I have presented this presentation twice at St. Croix and St. Thomas, and I just wanted to put it out in YouTube so everybody can have access to it. And it's called Proper Organic Matter Degradation. My name is Joaquin Chong, and I work at the University of Puerto Rico Agriculture Experiment Station. And this is what we will be covering, two general pathways of degradation. And I'm going to talk about briefly about compost and fermentation, the factors that affect composting, so temperature, which is what you usually measure, and other factors, and the fermentation process, so effective microorganisms, activation of them, and creating a substrate for inoculation. I'm going to talk about the difference between compost and fermentation. I'll give you a school fermentation example and a summary. So let's start with the two general pathways of composting fermentation. We have here on the left what would be a compost, which is an aerated static pile, and we have fermentation here on the right of usually things that contain quite a bit of nitrogen, things that if you leave outside it are going to stink, and it could include meats. It could include some oils, not that you're gonna use the frying pan of oil and put it in there, but it could include oils, and it could include things that you would not usually put in compost, which is on the left side. Then you can ferment. Okay, so let me tell you a little bit about composting. So composting can be defined as the proper control and mixture of organic matter types, which are called usually greens and browns, to promote aeration and aerobic microbe growth. So it means that it has oxygen. Okay. The thermophilic process, because it's a process that increases in temperature, usually on 130 to 150 degrees Fahrenheit. Uh, Later will increase in temperature, and later will decrease its temperature to ambient temperature. And then you will see that the organics are not what you originally started for them, and you are not going to be able to know, well, which organics were, what were they, the original matter, and it acquires an earth-like smell and is beneficial for plants. And if you do it properly, you will not have weeds. It should not stink. That's usually what a compost is. Okay. Now, fermentation, on the other hand, is also called Bokashi, and is controlled anaerobic digestion of organic matter without putrefaction or objectable, stinky odors. Let's put it that way. So it is without oxygen, so it means that you can compress the organic matter. It means that you can have the organic matter there that usually contains a lot of nitrogen, and it requires the inoculation of specific microbes in there. Ideally, for large amounts of nitrogen containing organics like manures, food residues, including meat, greens, and things like that, that would otherwise will just rot. You can use the leftovers, bones you can put in there, and you can put many things. So, but you can inoculate, and it requires a second step of degradation. Okay, so let's talk about the factors that affect composting, now that we know the difference between composting and fermentation. And then let's go to fermentation. Okay, so the factors that affect the compost process, which is, as I said, is aerobic, is particle size. So if you have small particles, they will degrade faster than large particles. If you have aeration speeds, it will, if it's well aerated, it will not stink, and it will speed up the process. So you want to create methods of aeration which could be passive. The carbon to nitrogen ratio, so that it would be, let's say if you have browns, which are called browns, things that look brown, paper, newspaper, hopefully your ink is soy based, or your ink doesn't have any heavy metals. And then you will mix it three parts brown, 1 part green, and that would sort of be ideal. But you know that if you have like a lot of greens like broccoli and many things, that skins and things like that, coffee pulp, uh, it's too much, what could be considered too much green, and it will stink, it will go anaerobic, and you don't want that. So you wouldn't have a proper compost if it stinks. Humidity is very important. If you have very little humidity, nothing will happen, because microbes need that water to um, to work. And if you have too much, it will also stink. So you sort of want to be around 40 to 50% humidity. And the way you know that is you go into your pile, you open it up, and um, you take a handful of it and you squeeze it, and if water comes out, you have too much humidity. If it stinks, you more likely have too much humidity, or you have too many greens, and you need to amend your compost with other things that are more dry in order to decrease your humidity. But usually what we do is that we measure temperature. We Humidity we measure with the hand, or we measure temperature with a thermometer, or we just put a stick on it and take the stick out and find out if it's warm. And it should be warm by the second day after you mix it. Usually temperature, what it happens is that it's at ambient temperature, it goes up pretty quickly. The faster it goes to 140, 120, the better. And then you keep those temperatures, you're going to keep those temperatures, the reaction is going to happen. If you know, by some reason the pile that you're building collapses, you know, temperature might decrease, and you might need to turn it. And when you turn it, or you add water, you know, it could be then you know, it will increase in temperature. As long as you have increasing temperatures, it means that you're not done. As long as you smell it and it doesn't smell good, you're not done. If it smells like ammonia, you're not exactly done, you know. You might choose to use it that way, but it might not be done. So all this particle size, aeration speeds, the process, carbon to nitrogen ratio, humidity, and temperature, those are all factors that interact between each other. And you know, we need to make sure what happens, you know. So I'll give you a few examples on temperature. This is called an aerated static pile. It has some PVC tubing at the bottom, and it has some holes, and you just put the organic material. This is coffee pulp. You put it on top, and you fill it up with a bucket, and it will aerate passively through the tubing. So if you go early in the morning, you're gonna see some steam coming out of the pile. This is an example of how to use temperature to measure and make evaluations. You put a thermometer in, you put it in the center of the pile, you take it out like a foot, you take it out like another foot, and in here you can see 90 at the center, 100 coming up, and then 110. So it is colder inside, and it could be lack of aeration, it could be that it's too wet on the inside, it could be many things that you know, that tells you it is colder inside. It should be about the same all over the pipe. We sometimes cannot build the pipe properly, and sometimes those things happens. So how are you going to remedy this 90 in the center? You might have to turn your pile, you know, if you know. But ideally you don't want to do a lot of work, so you know, you might put pipes underneath to make it aerated. You might put a pallet underneath. So those are the things that you could work in order to have at the beginning, so you have less work later on. Okay, so now let's say you have 90, you have 89, you pull it up a foot, you put it on a foot, you have 91. So it's about the same for the pile, is about the same temperature. So what does that mean? So lower temperature of the compost pile. How old is the compost? Is it, did you created the compost a long time ago and this is stable? How does it look? You know, is the compost finished? Are the materials too brown so you don't have a lot of nitrogen in it? Is it too dry? You know, is it too wet? Those things could happen, and that those things, you know, will make it, you know, it is a thing that, you know, will not cause your your pile. Your pile will be at ambient temperature. Okay. So another example would be you had 121, you pull it up a little bit, you had 120, and then you pull it a bit, and you have 119. So it's about the same. You have on average the same. So what does it mean? If you created this pile yesterday, it means it's heating up. If you hit 150, you will be even better, but you might not hit 150. Your construction of your pile, of your mixture of browns and greens might lead you to 120 degrees Fahrenheit. So yeah, it's not gonna heat up, but it's working. The pile is moving through its composting. Maybe if you add more wood chips, maybe it will heat up more, but then evaporation will come in, and then you will need to add water because you don't have a lot of water, and you might need to turn. So if I have a pile of 120 and I use quite a bit of greens, I might just leave it like that, not turn it. You want to reduce work. That's the thing. Is it working? Yeah, it is a pile that is proceedingly properly. You have to consider how old it is, at what stages. Temperature needs to be measured at least twice a week. Let's say you measure twice a week if you really want to be like if you want to pay attention all the time, and at the beginning especially because you want to learn and you want to see that temperature going up, staying up there. If it decreases, you want to find out why. If you add water, so those factors that affect composting, you want to check them out and see what's happening with my compost. Remember, if it stinks, it's not working properly. Now you might have some chicken manure and things like that naturally smell because the pH is pretty high. And for those, you might want to treat through fermentation. I'll talk about that briefly. Okay, so temperature is used to monitor the composting process. If temperature does not increase after mixing a pile, there is something wrong. It should start heating up after 12 hours. The faster it reaches more than 120, the better it is. And low temperatures could be due to low or high humidity, not a proper carbon to nitrogen ratio, or browns and greens. The mixture is too dense. It's like really heavy, and you need to open it up. Or it could be because you're finalizing the composting process. Okay, so let's go to fermentation, which is sort of like it's a fun part. I really enjoy fermenting. And how do we ferment the organic matter? We do Bokashi is anaerobic degradation of organic matter. It's how it's called in Japan. It's non-putrefactive, or it's fermentative. It's not gonna rot. Okay, you must inoculate with proper microorganisms, which are like these ones here. I will put a link in the description. And for people at the Virgin Islands and Puerto Rico, I will put an email, because you will have to email the company to get these microorganisms. And the company is called Terra Garnix. They sell the microorganisms, and you can buy them by 5 gallons, or you can buy them by the gallon, or even people that use them, they could buy them even in larger quantities. So it was developed by Teruo Higa in Japan about in 1970s. There is a book very interesting about effective microorganisms, and I really enjoyed reading how he really discovered it. And he's an emeritus professor at Ryukyus University in Okinawa, and he's the director. I'm not sure if he's still the director, but at least when I read the book, that's what it said. But so he developed the effective microorganisms, which is a consortium of microorganisms. I'll talk about it what they have, but it basically you have aerobic and anaerobic microorganisms working on a solution and staying in this solution. Okay, so the principal ingredients of this is lactic acid bacteria, which produce lactic acid and produce fermentation, phototrophic bacteria, antioxidant production, amino acid, sugars, and physiological substance which are active, and yeast that is used for producing bread, fermentation, and beer, and molasses and water with no chlorine, preferably. Okay, so let's talk about the activation of the effective microorganisms. I usually buy 5 gallons, which are in Puerto Rico about $361. I get molasses, which are about $10, and with that I can create 100 gallons of what is called activated EM, which is about 372 per gallon. And this is the way I do it. I dilute the molasses and I prepare the microorganisms. I dilute the molasses in a bucket, and I dilute it. You have to dilute it pretty well, so you gotta make sure that it's well diluted. And then I add the effective microorganisms. I fill it up to about 3/4. Dilute the molasses and then add the effective microorganisms. And you can put what is called a seal tight with water bottle, so if you have gases being produced, then they will escape through there and it will not explode. Usually if you do the mixture properly, 5% each, I have not seen it producing a lot of gases. Or you can vent it out every day, so you will have to, with no chlorine water. Okay, so 5% solution in 40 gallons, for example, you will need 2 gallons of EM, 2 gallons of molasses, and you need to wait about 2 weeks to get the activated EM, which is going to be at a pH of 3.5. Okay, how to use the activated EM? What I do is that I take one part of the activated EM, so from those 100 gallons, and mix it with either 16 to 20 gallons of water. And so that dilution will give me about 18 cents to 23 cents per gallon of cost. So, and I go in and spray what I need. So I can spray organic matter, or what I need, I will spray it. Okay, so I can use many different ways of spraying the organic matter with that dilution. And I can use either a motorized backpack when you have tons of organic matter you want to take care of. If you have contamination, like wood chips that have been contaminated with black waters, you can spray those wood chips and remove fecal coliforms with it. There is a publication by myself and Dr. Dumas, and I'll put a link also in the description if you want more information about it. So if you want to, let's say, let's create a substrate. Why would we create a substrate? One of the things that we do is that we can create substrates to spread the effective microorganisms. The best thing is to spray. For me, the best thing is to spray them and inoculate the EM, but substrates can be used to spread and inoculate microorganisms in other locations. So you can use the organic matter ideally for restaurants. So you can go in and, for example, take a coffee parchment and lay down the coffee parchment. The coffee parchment is what you take out. You take out all the coffee pulp, then you take out the coffee bean, and then there is a parchment that is enclosing that. So which looks like here on the right side, and you spread that in, and you take your diluted activated EM and just go in and spray it, turn it quite a bit, spray it again, turn it quite a bit, spray it. And so you're gonna find that you're inoculating that. You let it dry and it's there. The microorganisms are there, just sitting there, waiting to inoculate other things. And you can use shredded paper, with shavings, with dust, spent grain, with wheat bran, and many other things that are organic that you can later use to spread in organic materials. Okay, and let's go back a little bit. Why would you do that? So let's say you have chickens, and now I'm not an animal expert, and we have had experiments where we have fed effective microorganisms to chickens, but but you gotta make sure that when you do your activation and when you do all your process, you're pretty clean, because you wouldn't like any other thing to run in there. You have to keep it enclosed, so you keep a proper mixture. Okay, so what I'm saying is that you gotta find out if it will affect your animals, because You know, I don't think it will. You know, I don't think it will have. But you might want to try it first on a few animals and see how it works. Okay. Now, and so you want to use this substrate to have the microorganisms. So when the animals like chickens will go in and do their poop and do their thing, you know, that is already inoculated with effective microorganisms, and the ammonia won't be as hard. Okay, so that's one of the things that you might want to consider. Okay, so if you want to like go to pick up things from a restaurant, you say, oh, you know, every time you put in this bucket, you put organic matter, just takes a handful of this substrate and dump it in there. Okay, you dump it in there and you're inoculating these effective microorganisms there. So that's very important, because otherwise it will rot and stink, but if you have these microorganisms, it will not. Okay, so let's talk about the differences between compost and fermentation. Compost is controlled aerobic degradation of organic matter, and what usually happens is that it's hard to keep that control of aeration, so it goes anaerobic, it will stink, and many other things. And fermentation is anaerobic degradation without the stinky odors. You need to avoid meats and oils in composting, but you can do fermentation with any organic matter. It doesn't mean that you're gonna add the whole jug of milk there. You could if you have enough substrate, but it doesn't mean that you're gonna add all your oil in there. So I'm saying that if your food has some oil, it will be okay. So you can do rice, for example. It requires a proper carbon to nitrogen ratio, but in fermentation, the carbon to nitrogen ratio is not that critical. It's not that important, okay? Especially when you do the two-step fermentation process. It requires aeration, the composting, but there's no aeration required or needed in the fermentation. Okay, it renders a beneficial product with earth smell, and the ferment smells. It will smell, but it will not be stinky, and it requires a second step of stabilization. Temperature increases during the process in composting and later decreases, and temperature can increase during fermentation when you're fermenting directly with no second step. So it means that if you're creating like a compost pile, you can add the effective microorganisms there, and since these are facultative microorganisms, you are going to have some microorganisms that are going to be working on the outside of the compost, so you don't have to tight seal that. It will work in keeping your inner pile fermenting. Does not require inoculation, and it requires inoculation. Fermentation requires inoculation. Okay, so I'll give you a brief summary of an example of a school. This is by this teacher, Yadira Vasquez. She is at a school in San Juan. And what I did is I went in and talked to a few students of her about, how fermentation works, so they understand how it works. And we created these piles. You have 2 piles, 5-gallon buckets, okay? And you create some holes on the top pile, so that will allow to drain any liquid. And you start putting your food there, and then you put a lid on it and you press it. It's very important that you also put a top lid, and these things are enclosed because you can keep all the material there for like a month, or maybe even more, but you need to enclose it. Okay, so this is the 2-bucket example. So this is how the material looks after a while, after it is being collected. And this is an example of some other material that is being fermented, all organics. You can put in there, and every time you go in there, you spray the material and put it there. Okay, and then you have the bottom part. This is what will drain down there. There are some oils and things like that. So after we were done picking up all the material from the cafeteria, from the leftovers, we open it up a hole and we just put it in there, in that hole, and then we cover it. Now some people have asked me, like dogs might go in and want to eat it, so you want to maybe put some on top of it, and maybe rats. I've never seen a rat, but it could be. So you could just because that's fermenting, you could just put a top on it to avoid that kind of animal. Okay, so we made the hole and enclosed the material there, and we had a little bit more microbes there on top just in case, and then we closed it. And so this are the pictures after a month. We opened it up and we couldn't see anything after a month. This is, for example, the pictures of a lot of rice and beans leftovers, and this is a month after, so you might see some fungi growing in there, but the original material is not there. Okay, so the results were, they have about 400 students per day that eat at the cafeteria. They rescue about 300 pounds in 11 days. So they rescue about 26 pounds per day. And those 26 pounds for the 400 students they have, so each student would produce 0.06 pounds per student. So it means that every 15 days or so, each student will produce about a pound. Okay, and so they rescue about 300 pounds in this location, and they put it on the soil, and so you can see that it's a good advantage because it will not sting, it will smell fermentative, but it will not rot. Okay, so quick summary. Temperature is what you would use if you're composting. You need to measure it and you need to see how it works, but when possible it's better to ferment the material and further degrade the material into wood chips. So you could put, once you're done with your fermenting, you can go into a compost pile with a lot of wood chip material and you make a hole in it and put it there. Okay, so and then the activated EM can be fixed into substrate, so it can be used later for inoculation or for animals. And EM will reduce odors, will reduce flies, and you can basically do any organic matter. Okay, it's ideal for apartments. I have two buckets at my apartment when I'm in San Juan, and what I do is I inoculate them, and I fill up about 2 buckets a month, and after 2 months they weigh about 35 to 40 pounds, and I take them to a compost location, open the soil and put it there, and basically I'm recycling all that material. When restaurants do this, they don't have to call their trash pickup all the time. They can delay that so they can save money on that pickup, because their general trash is cleaner, so it doesn't stink, and the organics are in another side. Okay, so if you have any questions, just let me know. I do run this Composta PR channel with my friend Luis Reynaldo. I usually record him, and these videos are usually about gardening and things like that, but I just wanted to put this video out for the benefit of the Virgin Islands and people that talk English, and so we can outreach this technology, because it really works, and you will find. So I'll put a few links in the description about the company and things like that sells this material. Thank you very much.